Okay, hi everyone. This is a workshop for learning Git presented by the content team of Hacks. I'm Terry and my partner is Ben, and we'll be leading the workshop today. So I'll be going over the first half of the workshop, and then Ben will do the second half. Okay, so before we begin, it would be great if everyone could open up this link. It's basically just a feedback form so that we can make workshops better in the future. And then I'll just give it really quickly. You can feel free to fill in some of the boxes during our presentation if something pops up, and also have a link at the end of the workshop too. Okay. So the goals for this workshop are first to understand or get a better understanding of Git's conceptual model. Second, to learn commonly used Git commands, and then lastly, get an introduction to some less common but still powerful commands that Git offers. Okay, so I had the installing Git slide up earlier before the presentation started. But in order to follow along with the examples and play with Git, we'll all need to have it if you don't already. And the instructions for installation on Mac and Linux are here if you need them. For other distributions such as Windows, you can use the link at the bottom. Like for Windows, it's like super easy to install. So I'll give it another few seconds just in case anyone joins, and so everyone has time to do the installation. And then for the recording, feel free to just pause and then we can move on from there. Other than that, other than Git, this is pretty much all you'll need the workshop, other than some like text editor or code editor, which we should all have. Okay, here we go. So what is Git? So to summarize what Git is as briefly as possible, it is a version control system. So I stole this picture from last year's workshop, but basically version control is a system that tracks your changes and records multiple states of your work. Version control systems are pretty much used everywhere in the CS field since they're the best way to keep track of your changes, updates, whatever, and also access them at any point. And as an organizational tool, Git is also super powerful when you have to do collaboration with others. When I first started using Git, it kind of reminded me of playing Game Boy games on an emulator and using save states to prevent myself from dying and stuff. So in other words, it's super convenient and powerful if you learn how to use it. Now, you might be confused about the difference between Git and GitHub since those two words are bounced around a lot in the CS community. So to clarify, Git is the version control system itself that lets you manage and keep track of your source code. And GitHub, on the other hand, lets you manage Git repositories over the web. It's known as a hosting service. And its primary goal is to allow people to easily share their local repositories on the web. And we'll get into local and remote repositories later. But for now, you can just create a GitHub account if you don't have one. So I can lead us through that real quickly too. Let me create a new share since I'm already logged into mine. So if you just go to github.com, you can sign up here and then you just put in a username that doesn't already exist, your password, and then do an account verification. And then probably have to do an email verification as well. And then it should be pretty straightforward though. Okay, let me switch back. Ben, am I showing the slides again? Can you verify?
Yeah, you are.
Okay, cool. Okay, so in Git, the repository is the main structure that people work with. It's essentially a collection of files that make up your project or work. And what Git will do is it will track how your repository changes with time. So first, we're going to talk about 3 ways in order to get a repository onto your local computer. So the first one I'll show is from the command line. Actually, I'm just going to share my entire screen at this point. Okay. Can you see the command line, Ben? Okay, yeah, so I'm just gonna go to some temporary folder. And the first way you can do it is after installing Git, you can use the Git command git init and then some repository name. So here I'll just do test repo 1 or something. And so it says initialize an empty Git repository, and then in your file directory, the Git repository is just represented by a folder. So if I go to the, here, let me delete this one. If I go to my temp folder, I can see the repo was created here and it has the .git file there as well. And so that's like one way to just build it from scratch. And then another way is to go into GitHub and then create it from there. So I can quickly show that as well. On pretty much any page in GitHub, you can look for this new button, and then it'll direct you to this page. And then you can similarly type a repository name, type a description, and then choose if the repository is public or private. And then also optionally include like a README file and a few other things. So that's pretty simple. And then the last way is to clone an existing repository onto your local computer. So for this, let me think. I'm gonna go to the web dev workshops repository from a few weeks ago. So they have this nice repository here on GitHub. And so if you want to work on existing repositories, you can click on this code button and then copy the link. And then back in your command line, you can type Git Clone and then copy paste the link here. And so what that will do is that will take the remote repository and then copy it onto your local computer. So if I can actually show that. So as you can see, this repository was copied here. So those are the three ways. We have Git init, Git clone, and then also just creating one on GitHub. And then you're going to have to clone it as well if you want it on your local computer. So I'll give a couple seconds if anyone wants to like play with that. Pretty fun. Let's switch back. Okay, so now that we have a repo, what can we do with it, right? So if this repo holds all of the files to our project or what we're working on, then one thing that we probably would want to be able to do is to add a file to it. So let me just create a random file. For example, I can go to my notepad and then just create a random file and save into my Git repo and see what happens. So let's save as, and then I'll do this one that I just initialized. Let's do like test.txt. I'll save. And so what I did was I just saved a file into the folder that my repo is created in. But I need to tell Git that I'm going to be adding it to this repository. And so that's where the first useful command comes in, and that's going to be git add. So that's when you take your working directory or files in your working directory and add it to the staging area. So if I move to, let's see, what was my repo name? It was test repo 1. So first I'm going to move there. And then another really useful command is git status. So Git status just shows the status of the current directory and the staging area, and it's pretty useful if you forgot like which files you've modified or staged. And so after typing git status here, we can see we're on this branch master. I'll talk about branches later, and then we have no commits yet. And there's this untracked file test.txt. So what this means is that there's a file in the folder that has not been added to the repository, but it exists in the folder. So what I want to do here is I can do git add and then add that file to the staging area. And the staging area is like a docking point for where you want to push up all your work to a save. So the next step would be git commit. So to explain what that is, a commit is just a set of files that like represents the state of your repository at a specific time. Each commit can be linked back to like its previous or like its parent commit. And this is how Git keeps track of the history of your project, right? The series of commits. And each commit is also named by unique hash, which we can take a look at later. Which is also really useful, like for knowing which commit is which. So let's go ahead and do that. So if I hit git status again, let's see what happens. So there's going to be this new section that says changes to be committed. And so these are the files that were added to my staging area, and it's in green and says new file test.txt. So I can go ahead and commit this by typing git commit, and then I can also optionally add a message that like gives a description of what I did, and that's it. So here I can say added new test file, and then commit that. And then you'll get a couple lines of text as confirmation. And usually what I do is I'm always spamming Git status just to make sure. But you can see Git status means that it says the tree is clean. And basically it means that there were no unsaved changes that we need to make. And so I just add a new file, but I can easily go back and do the same thing. I can come back and modify this file, so I'm going to add some new lines. Save that. And then if I hit Git status again, it'll say that I've modified this file, and it knows I modified it since I previously added it to the repository. And so Git is keeping track of the modifications to each file. And then after I add it again, and you can also use something like git add star to add all the files if you have multiple files that need to be added to the staging area. So I just made a second commit. And essentially what we've done is we've worked on the left side of this diagram, which is our local repo. So I have my changes in the working directory, and then I add them to the staging area. And then when I commit it, it gets permanently saved into the repo. And if you can do all the things on the left side of this diagram, which is like adding new files or changing them and then adding to the staging area and committing, that's like the bare minimum for knowing how to use Git. And you can now go ahead and make some repos and work with them with any project. And when you save your work, just do a git commit. The first time, let's see, let me make sure I hit all of this information. Okay. So now let's talk about local versus remote repository. So the local repository is just a repository on your local computer, right? But if you want to be able to share your work with other people, you're going to need to copy it to a remote repository. Or if you want to look at other people's work, you're going to have to clone it from a remote repository. So what I want to do, what I want to show here is that on my GitHub account, I currently don't have this repository on my GitHub account. So what I want to do is push it up there. And to do that, I'm going to use git push. And so actually, even before this, if you're like a first-time user trying to do a git push, you'll probably get an error message that says like you need to connect to an account. And so it's going to look something like, oh, I need to open up a target. It's going to look something like this. So it's going to say git config -- global user.email. So basically what it wants you to do is it wants you to enter the credentials for your remote account. And so you're going to have to do something like this in order to connect your GitHub account to your local Git. And then after you do that, then you should be free to push, pull, and do whatever you want. So here it says what we want to do is add some name, because my remote repository doesn't have a name. I'm just going to add some here. Oh. Push the current branch. Okay, so this is actually, so what should happen here is that I needed to connect the upstream branch to this repo. So let's see. Actually, an easier way might be this one that's already connected. We have the web dev one. Let's see. What's it called? So I can actually make edits here as well. And actually, it might be better here because there's actually a lot of files. So if we go into this repo, there's already 3 files that they created here. And then let's see. This actually segues into my next section, which is branches. So actually, I'll talk about branches first. So when you're working with branches, one of the biggest reasons why Git is useful is that branches are an organizational tool to help you organize your edits. And so, for example, say you're working on a large project and you're tasked with adding a small feature, you could create a branch like specifically for that feature, and then add your commits to that branch only. Oh shoot! I just realized there was something in chat. Oh, my bad. Can y'all see my video now? Okay, I'm gonna assume that's yes. Basically, this way you can, if you have branches, you can take control of the version control system on your own branch while others work on the main branch, other small branches. So for a branches example, I'll just go into the web dev repo that we already have since there's a lot of code there. Let's see. I'll open up the index file. And let's say that I was working on some small feature to change like the front page of my website. And so let's see. Oh, first, a useful command is git branches. So it'll show oh, it'll show all the branches that are currently available. So right now we only have the main branch, which is called master. Right. If I wanted to create a new branch, let's see. I could use git branch and then add a name, and then it would also show up under the branches list. So in order to move from one branch to another, what you want to do is to git checkout and then type the name of your branch. And then I can hit git branch again, and then it'll show that we're on the bug one branch. So what you want to do is generally you want to organize these changes or these whatever your like smaller tasks into your branches. And so I'm just going to change this like my personal website to like Harry's website or something like that. And then if we save that, let's see. I want to show that it'll only show up in this bug one branch. So let me just add it. So everything's good. Remember I'm currently on the bug one branch. And then if I switch back to my master branch, so in my file, it'll actually change it back to whatever was on my main branch. So it says my personal website again. And then what happens is when you're done working on your small feature or whatever small task you're working on, you can use git merge in order to combine your changes back into the main branch. So here I'm going to do that. And here you want to make sure that you're already on the branch that you want to merge into. So if I want to merge my bug one branch into my main branch, then I have to be in the master branch. So and so that means the merge work, and I can go back into the code and see that that change was reflected in the title. And so that's just a brief overview of branches. And then I'm going to pass it on to Ben in order to talk about some more advanced features.
A second, let me just. Can you guys see my screen all right?
Yes.
Okay, great. So we have the basic idea with branches and remote repositories, local repositories, things like this. So one common situation that arises every time you have branches is when you're working on a feature branch. So this is indicated by this gray branch here. and then people push commits to master, or people merge other commits to master. So now we have something called a diverging history, where feature no longer, it shares a common ancestor with master, namely this one, but now it's like the way won't be clean. Then you have it won't look like a linear history. Basically, the history is no longer linear, right? So Git is very powerful in that it lets you rewrite history. So one example of this is Git Rebase. It will basically replay the commits as if you branch off the latest master. Of course, if there are any merge conflicts, then you'll have to handle that as well. But then in most cases, then this will work just fine. The only requirement is that you also have to force push. Force pushing means when you Git is so powerful that you rewrite history, and you can force these changes onto the remote repository. There's a downside to public history, so this is not recommended if you have public history. For example, don't force push to master like this. But I'll give an example demo right now. Can you guys see my terminal window? Is it clear? Do I need to make it bigger or anything?
Yep, I can see it.
Okay. Yeah, so I have an example repository here. Let's say I have the branch I just created for this. This is somewhat of a large repository, so bear with me. I guess it will demonstrate the output that it will work even across tens of thousands of commits. So this is a very active repository, for instance, an open source project. So in this branch, you can see that the latest commit was made in December of 2020. Right? So let's say I wanted to add some commits from that, and the difference between this branch and master is like 22,000 commits. So let's say we wanted to make some changes to README for some reason. So I just made a little change here. And I'm adding it to the just add and then commit a message saying now suppose I wanted to rebase onto master, then I can just simply do git rebase. Maybe I should have chosen a smaller repository because this is pretty large. But basically, it will do exactly what this picture shows. In that it will take. So the situation is currently this: I have one commit extra here that does not appear in master, and to have a clean history, I can sort of like replay on top. See. Looks like the rebase won't be clean here. That's not to worry. And in most situations, it's simply a matter of doing git rebase status onto, and then followed by the branch that you want to rebase onto. Okay. Here's another motivation to use git rebase that you can use it to sort of clean up your Git repository. So it's very often the case that you can commit a lot of things. There's a lot of work in progress things. And let's say you want to rewrite things to make it look like you develop things correctly or in line or in a certain order. So Git Rebase allows you to interactively rewrite history and also rearrange commits and also merge commits and delete commits that you don't need anymore. So basically, you can really clean up your branch, feature branch, before it gets merged into master, right? So that the Git history remains logical and not sort of some sort of tangled like backlog. Other useful command that I've done, I want to cover briefly a bit here is git cherry pick and git bisect. So git cherry pick lets you sort of choose selectively commits from one branch to apply on a different one. So let's say you have a bunch of commits and you implemented maybe 2 features in one branch, but then you realize you really should have made another branch to begin with to separate out. So git cherry pick lets you select those commits pertaining to that other feature and create a new branch as you want. Another one that's very good is git bisect. So if you're taking 2.2.1 currently, then you know that binary search on a sorted array, for instance, lets you find the element in log n time. So let's say you have a nasty bug in your program, and it occurs somewhere in Git history. but you don't know when. But you knew that like 6 months ago, like, the problem wasn't here. So Git Bisect will essentially do binary search, let you do binary search on the repo history. So here's an example, a real life example. I think it's visible, right? So real life example, the same repository package manager that I showed before. So I had a nasty bug where the package wasn't building anymore. So then I wanted to see if it was still building. So I checked out 15,000 commits ago, and it was still working. So that this is a natural use case for Bisect, and Bisect can even automate certain aspects of it. For instance, based on a test script that you might run and check the error code. So here it was just simply like, is the package built or not? Then maybe this took like an hour, 2 hours. It managed to find the commit that caused the issue first arose. So just glibc update. Right. And lastly, I have some tips for working with Git. It's a common beginner reaction to delete your repository if something goes wrong. I know I did personally. And this turns out to be quite a bad idea because Git is actually very careful about keeping track of the changes, right? In fact, there's also this notion of reset. So Git reset is also very important in that if you commit something that you didn't mean to commit, you can go back one commit like this, Git reset hard head. This will discard the last commit completely. But actually, it's not even completely gone because Git has something called a ref log. I should show it here. Basically, it keeps track of all the changes you have. For instance, I can adjust to the point before I made the adjust readme commit. For instance, let's go here, the Git log. I had the adjust readme, but if I do Git reset -hard head till the 1, this is like head -1. Head is where you currently are in the Git tree. Then you'll notice that the commit is no longer there, but it's not totally gone. It's still in the ref log, actually. Right. So now I can do Git reset head. Let's get one back into ref log. There's a button. Right. So here, if I run Git status, you notice that it says the read was modified, and I ask for the stage changes. Then it's like on stage. Git add readme.md. So this was stage changes, and you can see that I have example changes here. In this case, it went back to the point in time where I deleted the commit. Right. So more of the stories, don't delete the repository if something went wrong. More often than not, you should just read the error message, find your way around what you can, how to resolve the error message. And there's actually a great website here that will let you, that basically shows common situations. For instance, this is a common one, Git ref log. Will show you everything you've done across all branches, and each one's indexed by head. You can essentially reset. Or if you sort of have a change, you committed something and then you actually found out you need to commit something again. Or you need to change up the last commit. Let's say you have a typo. You can amend the commit. If you accidentally committed the wrong branch. So these are common commands. I highly recommend checking out the individual Git pages for this. Git has very good so-called man pages. I can do man git stash, and it'll show me the Git stash manual, which is very detailed. It shows me basically everything I would need. Right. Okay. Does anyone have any questions?
Okay. Other than that, I'm gonna pause recording. Unless Lockie, do you have anything else to add?
Nope, I don't think so.